Hey friends, we are going to finish chapter 1.11. This first thing is a review from day one. Is kind of drawing a graph given information. So let's take a little peek at this thing. So this is telling you, if you kind of look through your notation and think about what it means, this is telling you as x approaches infinity what the right end is doing, and negative infinity means it is going down. If you take a look at the notation for this second fact, x is approaching negative infinity, so that's going to be the left end of the graph. And since that is approaching infinity, that means that end's going up. Keep in mind, this is a rational function. So if the ends are going up or down like that, that's indicating that you have a slant asymptote. And in this case, for the right end to be going down and the left end to be going up, you're going to have a slant asymptote looking something like that with a negative slope. Okay. Then the next fun fact they're giving us is this, and we are approaching one from the left and going down. And so that is going to have to be a vertical asymptote value, because as you approach a vertical asymptote, you got to go up or down. And okay, now Penny's going to drink while I'm making this video. Okay, thanks, Penny. So here, as you're approaching that vertical asymptote at x equals -1 from the right, that is also going down. So we just need to kind of make sure we meet all of that criteria. And there's a bazillion correct answers, but the one I do is going to be the most correct, just because it's mine and because I said so. So the first thing I'm going to do is draw a vertical asymptote at x equals -1. That is something you absolutely have to have. And like I said, joking aside, you can have a lot of different answers. But then the other thing that I need is I need a slant asymptote that is coming down from left to right. I'm not going to care about anything specific. I just know that those first two facts indicate that I have a slant asymptote that has a negative slope. And now you can draw whatever graph you want, except that you need both from the left and the right of that vertical asymptote to be going down. So here's the left and here's the right. So here, in order for this to be going down, it's got to stay within the confines of these asymptotes. So it's going to be something like that. And then on the left side, it also has to stay within the confines of the asymptote, but I have to meet all of the criteria. So here is the left end of my graph, and it is indeed going up. So check fact 2. Here is the right end of my graph, and it is going down. So that satisfies fact 1 that we were given. And then the last two criteria are saying that on either side of this vertical asymptote, the graph is heading downward. So my graph meets all the needs. And like I said, there can be a lot of different graphs, but this is one. Okay, now on a totally different note, we've been working with rational functions, and a lot of them, most of them are written in factored form. And we are seeing problems where we have a power, but we haven't been multiplying out the whole thing. We've just been like, oh, this would generate an x squared in the first spot. This would generate an x cubed in the first spot. And that's been good enough for us to look at the leading term. But in real life, we're going to have to multiply those out, which gets annoying quickly. This word right here, tedious. This one's not so terrible because I can FOIL this out and we're super good at that. So x squared, and then the outside, and then the inside, and then the last. And so ultimately I would combine like terms and end up with x squared plus 6x plus 9. That is not terrible, but it would get terrible if I had to start doing higher order multiplication, because I would have to FOIL, which we just did up here. And so we'd end up taking x plus 3 times what we just got. And then we'd have to double distribute that, meaning go through and multiply this x by each thing, which would give me x cubed plus 6x squared plus 9x. Then I'd have to go back again and distribute this 3 to everything. So that would give me 3x squared plus 18x plus 27. And then I would have to put those together and get my answer. And I would look for, I just have this 1x cubed. I have a 6x squared plus 3 more. Excuse me. Plus 9x squared. I'm allergic to multiplying these out. Then I've got 9x plus 18x, so that's going to be 27 plain x's, and then I have 27 at the end. I'm looking at the notes key and there's a mistake, so I was just triple checking that that was right. Okay, so this is my answer, and that's fine, but that wasn't super fun, and I definitely do not want to tackle something that's higher power. Like here it says, what if we had to expand x plus 3 to the 7? I can easily know that the first term is going to be an x to the 7, but the other million terms, I don't know off the top of my head, and we are going to have to do that. Now, this notation is about as confusing as math can get, and it uses this, which we have not done. You've done it in a past class. You would have done like NCR. And so this is NC0, NC1, and so on. Making sense of that is going to be super confusing. So what we're going to do is just show what I'm going to do is just show you how to do this problem. This is going to be like the concept of what we're doing right now is this expansion. However, looking at an example is going to be the easiest way for you to learn this. So these numbers are what's called Pascal's triangle, and Pascal's triangle has like a whole bunch of weird math patterns that somebody with too much time figured out. Essentially what happens here as you build, you can see I have one in my first, what we call row 0. Row 1 has a 1 and then another 1. Row 2 has a 1, a 2, and a 1. And we would generate these by doing the combinations, this NCR business, but we don't need to do that. You're going to have a Pascal's triangle that will get you started, and then you can make when you're on your own, because in each in the first row, you can see there's always a 1, and the last number is always a 1. And then what I always think is that the second number is the row you're in. So this one doesn't have a second number, and that's row 0. Here, the second number is 1, and that's row 1. Second number is 2 in row 2. Second number is 3 in row 3, and so on. So what we have here is we have 7 rows. If we needed an 8th row, which we will for one of our examples, what you're doing from one row to the next is you're taking the sum of these two, and you'll see that that becomes the 4. 3 and 3 makes the 6. 3 and 1 makes the 4. And then they're bordered with the 1 and a 1. So since we're going to need a row 8, let's build a row 8. This is going to be a 1 because it always is. The end is going to be a 1. And then you already know that the second number should be an 8 since it's going to be row 8. And also it would be true because that would have come from this 1 plus this 7. So here we're going to add those together, and we're going to get a 28. And then we'll add these next terms together, and we're going to get a 56. You do have symmetry in this. Here we get a 70 in the middle. And then as we keep going, these next two numbers bring us back to 56. And then these two bring us to 28 again, and these two bring us to 8. And then we end with 1. So like I was saying, you'll see that they're symmetric. So for example, here in row 5, it goes 1, 5, 10, 10, 5, 1. And so there's just a lot of patterns that we could get into, but what we're really doing right now is just using these numbers to help us do what we're going to do, which is expand binomials. So this is an important piece of information that you want to make sure you know. It says the degree of the polynomial tells you which row of the triangle you're going to use for the coefficients. That is a key fact. Make sure that you make note of that and highlight it in your notes. Okay, so let's do a couple of examples just to make this make sense. So since this is in asking me to expand it to the 5th degree, I'm going to go ahead and use the numbers in row 5. So what I'm going to do is I'm going to have a 1. I'm looking at row 5 right here. And I know it's row 5 because the second number is 5. So I'm going to use a 1, a 5, a 10, a 10, a 5, and a 1. I guarantee I'm doing my spacing poorly here. So And then what happens is you think of your binomial as the first thing and the second thing. The first thing will start off as x to the 5, which is what we've been doing, knowing that the first term would just be x to the 5. And then it decreases by a power each time. So it goes from 5 to 4 to 3 to 2 to 1, and then you don't have one at all in the last term. That's what this business is talking about. Here you've got an n, then n minus 1, n minus 2. So that first term in your binomial starts with the highest power and decreases as you go. The flip version of that is that the last guy doesn't even exist in the first term, pops up here in the second, and right now it's to the power of 1, so you can see that these two will total the 5. In the next term, it will increase in power to 2, then it increases in power to 3, increases in power to 4, and then increases in power to 5. So as the x loses power, that second part, the 2, increases in power. One thing that students have a hard time with, here you can think of it like this too. Like this is basically 2 to the 0 power, and then 2 to the 1, 2, 3, 4, 5. And if you were thinking of the x's, they went 5, 4, 3, 2, 1. And then this would be like having x to the 0 power, which is just a 1 and doesn't actually factor in. So one mistake that a lot of kids make is finding the coefficient. Make sure that you remind yourself that coefficient is the number in front, because they're going to ask you for the coefficient pretty frequently. I'm spelling in my brain, sorry. And it is not the variables. So it doesn't include your x's, doesn't include your y's. It would literally be the number in front. So make sure that you remind yourself of that fun fact so that when it asks for the coefficient, you don't lose points. So what I will often do is you'll see on the answer key, I'll jot in like a numbers a row to think about the numbers. But here my number would be 1 times 2 to the 0, which is just going to turn out to be a 1. And so I just get 1x to the 5th, which I already knew I would get. Then I'm going to add, I'm adding these terms together because I'm going to be doing a shortcut version because I don't want to take x plus 2, multiply it by x plus 2, multiply it by x plus 2 a third time, and then a fourth time, and then a fifth time. I don't want to do that. So what I'm doing is getting the answer to that through this binomial expansion shortcut. So in the second term, I have a 5 and a 2 to the first power. So that's just going to make a 10 as my coefficient. And then I have x to the 4th. In my third term, I have a 10 and then times 2 squared. So that's going to generate a coefficient of 40. And then my x is cubed. And you just kind of keep going. So here I'll have a 10 times 2 to the 3rd. So the coefficient of this term is 80, and that is my x squared. In my next term, I have a 5 times 2 to the 4th. And if I do that out, I actually end up with 80 again. And it's, again, common for you to have repeating coefficients, so don't panic and think you're doing it wrong. And then last, that one is really all number because it's 1 times 2 to the 5th. And so that one turns out to just be 32. And that, my friends, is the answer for that expansion if I had multiplied these all by each other. So even though that seems like a lot of work, you're just using patterns and the Pascal's triangle to help you get an answer rather than having to actually multiply them all out. So trust me, this is much better. So let's try a couple more times with some differences in what's going on. Here, the difference is the subtraction, and that's why you have this note to be careful, because you do have to watch what happens as you do that. So here, I'm going to start off keeping in mind that this is my first thing and -1 is my second thing. So this is the row that I'm using. So up here, I'll be using row 4, and I know it's row 4 because that's the second number. So I'm going to shrink this down so you can see that. I'm going to start with 1 from here, and then I'm going to have, and you don't have to write these all out because I always do a poor job of spacing, but I'm just trying to show you that I'm stealing those numbers from the row. And now I'm going to take the first thing, which is 2x, and that is going to be to the highest power, and then it's going to decrease in power in each term. And it's going to essentially be to the 0 power in the last term, but I'm just going to leave it and not write it because it's just anything to the 0 power is 1. Then I'm going to go through, and here's where you have to be careful. This is a -1. I do not have that in my first term, but it introduces here, and that's to the first power. Then here it's to the second, and then in the next one it is to the third. And then in the last one, you're going to have that -1 to the 4th power. And the reason this is important is you can see that they're negative, and as you raise it to different powers, it's going to impact the sign. So for example, here, I'm going to have 1 times 2 to the 4th for my numbers. Here I'm going to have 4 times 2 to the 3rd because of this. But then I'm going to introduce a -1 to the 1st power, which is going to make that term negative. So when I look at my first 2 terms, the coefficient of this first one is going to be 1 times 2 to the 4, which is 16, and then x to the 4 because of this. But here, in the second term, 4 times 2 to the 3rd times a -1 is going to turn this term into a negative value. And then you get 32, and your x is cubed here. Now, it doesn't stay negative, though, because if you look at this next one, the coefficients are going to be 6 times 2 to the 2nd and -1 to the 2nd. So it's going to alternate, because now my -1 is to an even power, and it's going to become positive. And so now I'm going to end up with just 6 times 2 to the 2nd power. And I get a positive 24x squared. But I'm expecting the next one to be negative because I have 4 times 2, and then this -1 is to an odd power, so it stays negative. So the coefficient for that term will be -8, and then the x is plain. And then at the very end, you have that -1 to an even power again, and so it's just going to turn out to be positive 1. So that is the answer that I would get for this expansion rather than multiplying 2x minus 1 times itself. So make note of that, because when you have a subtraction rather than an addition, maybe put a little note on here. If you have like a minus b to a power, then you are going to have alternating signs. And so pay attention to that as you go. The first term's going to always be positive, like my 16x to the 4, and then they're going to alternate from there. So pay attention to that, because that's a really easy place to get a little tangled up. All right, now the reason we have to do this example is that each of the pieces has a coefficient. So this one just gets a little bit messy, and you have to pay really close attention to your number, which is why I'm writing those into my little gray ghost pen. So we are again in row 4, so we already used that up above. So I'm going to need a 1, a 4, a 6, a 4, and a 1. Okay, this is my first thing, and the 3x is going to be, I'll do that in a different color, sorry. The 3x is going to be to the 4th power to start with. And then it is going to, and the whole thing is to the 4th power. Then that 3x is going to decrease to the 3rd, then to the 2nd, then to the 1st, and then not there. Opposite, the 2y, which is the second part, is not going to be in the first term. It's going to show up in the second term to the 1st power. Then it's going to be to the 2nd power. Then it's going to be to the 3rd power. And then it's going to be to the 4th power. So as the 3x loses power, the 2y gains power, so that at any of these, you can see that the total power is still going to be 4. So here I have 3 and 1, so the total power is still 4. Okay, so here's where it's important to pay attention to the coefficients, because this is going to be 1 times 3 to the 4th. And so when you do that out, it's going to be 81x to the 4. I am not going to have alternating signs because I had a plus in between them, not a minus. So here you have to be careful. You got the 4 from the triangle, then you have a 3 to the third, and then you have a 2. And so 3 to the third is 27 times that 4 times that 2. I'm going to end up with a coefficient there of 216. My x is 2 the third, and then I have a y in this one because both of my pieces, the first piece and the second piece, have a variable. So that's new. Here I'm going to have my 6, my 3 squared, my 2 squared, and so the number part of that is going to be 216 again. Now my x is 2 the second, but my y is 2 the second as well. And this guy has a 4 times 3 times 2 to the third. So that coefficient ends up being 96. And you can see here the x is plain and the y is cubed. And in my last one, the coefficient part is 1 times 2 to the 4. And so I'm just going to end up with 16. And now I'm all on x's, but I have y to the 4th. So the three kind of versions are, the first one's pretty basic, x plus 2. The second one introduces what happens when there's a negative. And the third one introduces what happens if each of the pieces has a variable. And then from there on out, it's just practicing until it feels easy. So the process is a lot easier than actually multiplying those all out and foiling them and then multiplying by another one, another. So just keep that triangle in front of your face to help you out. Okay, let's wrap this up. This is a part that tends to give kids trouble, but we're going to make it so it doesn't give you any trouble. What is the coefficient? So your answer should be a number, not x's, not y's. Tell yourself that a million times because so many people lose points on the test because they write the whole term. The whole term, for example, would be like 3x cubed y. That would be the term, but the coefficient would be just the 3. So kind of keep that in mind. So this is asking you, what would be the coefficient of the term containing x to the 4th? So think about it. This is in the 6th row. So you would start with x to the 6, then x to the 5, then x to the 4. So if you think about it that way, you know that you're looking for the third number in the triangle. So if I go to the triangle and I'm in row 6, oh, Penny needs another drink, and I go to the 1, 2, third number in that row, that number is a 15. This would be x to the 4, and that would mean the 5, the second part, would have to be to the second power so that they can be 6 in total. But it's only asking me for the coefficients, so I'm going to take 15 times 5 squared because that's all it's asking me for, and I'm going to end up with 375 as my coefficient. I'm not putting the x to the 4 because it's only asking for the coefficient. Okay, last one. What is the coefficient, not the term, the coefficient of the term containing x to the 3 for this guy? Okay, this requires row 8, so we did add that onto our triangle earlier, so that's going to be helpful. But this one's kind of a journey, and we got to be careful. This guy has a negative, so we'll have to figure out if the term we are on is positive or negative. If this one is row 8, the first term would have an x to the 8, then 7, 6, 5, 4, and then finally 3. So we're going to be 1, 2, 3, 4, 5, 6 numbers into that row. So we need the 6th number of row 8. And the reason it's row 8 is we are expanding to a power of 8. So if I go back to the beginning of my notes and I look at row 8, the 1, 2, 3, 4, 5, 6th number is 56. So this is my 6th number. So I'm going to have a 56 from the triangle. I'm going to have an x to the 3rd, which means my second part of negative 3 has to be to the 5th so that these two total 8. So think about that. I don't care about this because it's only asking me for the coefficient. So I would have to do 56 times negative 3 to the 5th. And be careful, negative to an odd is going to be a negative number. So I end up with negative 13,608 as the coefficient. I am not including an X, a Y, or anything in my answer because they only asked for the number that would be in front of that term. So now you're an expert, and you're going to find that the homework for this just gets a little tedious, but once it feels tedious, that means it's going to be easy for you from here on out. So hope that helps. Bye, guys.